I'm modifying a scikit-learn estimator, specifically a decision tree classifier, to include pre-processing. I need to avoid changing the original estimator directly. This is a common task in machine learning pipelines. Let's dive in. I'm trying to figure out the best way to add pre-processing steps to my decision tree classifier without messing with the original object. I'm exploring different approaches using the Sklearn base clone function. This is key to understanding the problem. I'll create a complete, independent copy of my decision tree classifier using Sklearn base clone. This way, I can add pre-processing to the copy without affecting the original estimator. This is the correct approach. If I create a shallow copy with Sklearn base clone, changes to my copy will also affect the original decision tree classifier. This is incorrect. I need to keep the original unchanged. I'm using Sklearn base clone to make a deep copy, so changes to the copy will not affect the original. This ensures that my pre-processing steps don't mess up my original model. A shallow copy shares references, not data. This means modifying the copy also changes the original object. I want to avoid that. This would be incorrect. Manually copying all attributes is tedious, error-prone, and might miss crucial parts of the estimator. I definitely don't want to do this. I'm starting with a standard decision tree classifier from the scikit-learn library. Think of it as a pre-built machine learning model ready to classify data. I want to add some extra steps, pre-processing, to improve its performance, but I don't want to change the original classifier directly. This is the correct approach. I use Sklearn base clone to make an exact copy, a deep copy, of my original decision tree classifier. It's like photocopying the classifier. I have two completely separate, independent copies. Now, I can add my pre-processing steps to this copied classifier without affecting the original. This is wrong. A shallow copy is like just making a label that points to the original. Any change to the copy changes the original. I need a completely independent copy to make sure I don't accidentally mess up the original. Modifying the original classifier directly is a bad idea. It can lead to confusing errors later, especially if I'm using this classifier in a more complicated workflow. I should always keep my original model untouched unless I'm finished with it. Manually copying each part of the classifier is prone to error and won't get all of the internal settings, so I avoid this method. It's also not efficient. This is the result after I have successfully copied the decision tree classifier and added my pre-processing steps to the copy. I now have a new classifier ready to use with the extra steps added. I've improved my model while protecting my original. I'm modifying a DECISIONTREECLASSIFIER from the SCIKITLEARN library. I want to add some data cleaning steps before training the model without messing up the original classifier. This is a common task in machine learning. This is the best approach. I'll use the _Sklearn base clone function to make a perfect copy of my decision tree classifier. It creates a totally separate copy. Changes to this copy won't affect the original. Think of it like photocopying a document. You have two identical documents. I strongly advise against directly modifying the original DECISIONTREECLASSIFIER. This is risky. You might accidentally break things. It's best practice to keep the original untouched to avoid unexpected issues, particularly in complex machine learning projects. I could try copying each part of the DECISIONTREECLASSIFIER manually, but it's a bad idea. It's time-consuming, prone to errors, and I might miss important parts. A shallow copy is a problem. It only copies the top-level references, not the actual data. Modifying the copy would also change the original, which I'm trying to avoid. It's like sharing a Google Doc. Any changes you make will affect everyone else. This is your starting point. A pre-trained DECISIONTREECLASSIFIER from scikit-learn. I'll need to modify this to include extra steps before training without changing the original. Think of it as a master copy I want to keep untouched. This is the correct solution. I use scikit-learn's clone function to make an entirely separate copy, a deep copy. Any changes I make to this copy won't affect my original DECISIONTREECLASSIFIER. It's like photocopying. The copy is completely independent of the original. This is wrong. A shallow copy is like linking two documents together. Changing one will change the other. So, if I modify the shallow copy, my original DECISIONTREECLASSIFIER will also be changed, which I want to avoid. This is bad practice, and something I should absolutely avoid. I want to keep the original DECISIONTREECLASSIFIER unchanged, so directly modifying it introduces uncertainty and can lead to hard-to-find bugs. Think of it like directly editing a master document. It is generally not a good idea. I need to adjust a scikit-learn estimator, which is a type of machine learning model, specifically, a DECISIONTREECLASSIFIER. I'll do this by adding steps before the model learns, pre-processing, without affecting the original DECISIONTREECLASSIFIER. This is inefficient and prone to mistakes. Trying to manually copy every single part of a model is tedious and might miss vital parts. It's like manually rewiring a complex circuit board, highly error-prone. These are the extra steps I add to my modified DECISIONTREECLASSIFIER copy, either the deep or shallow copy. They prepare the data before the model trains, for example, cleaning or transforming data. This is the DECISIONTREECLASSIFIER after I've made a copy and included my pre-processing steps. It's ready to train. The core challenge is to add pre-processing steps to a DECISIONTREECLASSIFIER without directly altering the original classifier. This is important to keep the original classifier unchanged and maintain reproducibility of the experiment. We need a strategy that creates a modified copy while leaving the original untouched. This is the correct approach. Sklearn. Base. Clone makes a complete, independent copy of the classifier. I can then safely add my pre-processing steps to this copy without worrying about changing the original. Think of it like photocopying a document. You have two identical, independent copies. This is wrong. A shallow copy only copies the references, not the actual data. Imagine two labels pointing to the same underlying data. Changing one automatically changes the other. Modifying the shallow copy would modify the original classifier. This violates the requirement of leaving the original untouched. Manually copying each attribute is tedious, prone to errors, and risky. I might miss crucial internal details of the classifier, leading to incorrect behavior. It's not efficient and not a reliable approach. This is a bad idea and should be avoided. I must never modify the original classifier directly. This can cause unpredictable problems, especially in complex workflows or when using parallel processing. It violates the principle of leaving the original estimator untouched and could lead to debugging nightmares. This refers to the overall task. I want to change a scikit-learn decision tree, DECISIONTREECLASSIFIER, to include extra data cleaning steps before it learns from my data. This is your original decision tree model. I don't want to change this one directly. I want to keep it untouched. This is a scikit-learn function. I'll use it to make a perfect copy of my original decision tree. Think of it like making a photocopy. The copy is exactly the same as the original, but if I change the copy, the original stays the same. This is the perfect copy that I made using Sklearn. Base. Clone. I can now safely change this copy without affecting the original. These are extra steps. I'll add them to my cloned decision tree to prepare my data before I train the model. For example, I might scale my features to have a similar range of values or convert categorical features into numerical ones. After I add my pre-processing steps, this is my improved decision tree. It's ready to learn from my prepared data. This is the right way to do it. I use Sklearn. Base. Clone. To make a deep copy of my original decision tree. This ensures that any changes I make to the copy won't affect the original model. Manually copying the original model's attributes would be difficult, tedious, and prone to mistakes. It's not a smart way to go about this. A shallow copy would share the same memory space as the original, so changing the copy would change the original too. This is a big no-no. Changing the original decision tree directly is very risky. This is bad practice and it can lead to unexpected issues later on. This problem challenges you to improve a decision tree classifier from the Scikit-learn library by adding pre-processing steps. The catch? You must avoid altering the original classifier. I'm testing your understanding of how to safely modify estimators in Scikit-learn. Think of it like making a copy of a recipe before adding your own special twist. You don't want to mess up the original recipe. This is the correct approach. I'll use Sklearn base clone to create a perfect copy, a deep copy. This means I'm making a completely independent version of the decision tree classifier. Any changes I make to this copy won't affect the original. It's like photocopying a document. The copy is completely separate from the original. This is incorrect. A shallow copy would only create a superficial copy, and both the original and the copy would point to the same data in memory. Imagine a shared Google Doc. If I edit the shallow copy, the original will also change. This is not what I want for this question. Manually copying all attributes is a risky approach because it's slow, prone to errors, and I could easily miss crucial elements. This will be very messy to manage. It's like trying to hand copy a whole book. You're very likely to make mistakes and not get it perfect. This is a bad idea. Changing the original estimator directly can cause unpredictable problems later on, especially if I'm working with larger projects. Think of it as drawing directly on a priceless artwork. It's irreversible and could cause significant damage. Not a good idea. This whole quiz focuses on safely modifying a Scikit-learn decision tree classifier. Scikit-learn is a popular machine learning library in Python. A decision tree classifier is a type of machine learning model used for classification tasks. I need to understand how to work with these models safely and efficiently.